On July 1, 2026, a squadron of F-16s landed at their home base in Germany, pulled out of the Middle East after a ceasefire held. The mission was done. 6 days later, the ceasefire wasn't. On July 17th, 4 flights of 3 climbed out of Spangdahlem and turned east, a package of tankers running ahead of them. 16 days back on the ground, most of it watching the agreement they'd come home for come apart. Here is where it gets strange. The region was not short on air power. More than 330 American aircraft were already spread across 3 major bases in theater. 2 carrier air wings were working offshore. Another 113 sat within reach. Among them, 13 F-22s, 48 F-35As, 40 F-15Es, 86 tankers committed or inbound. With all of that already in position, the aircraft the Pentagon moved on short notice was a design from the 1970s that shows up on radar exactly like every other conventional fighter. That decision only makes sense under one condition. There has to be a task in this campaign that specifically calls for this airframe, badly enough to fly a squadron back across 2 continents. That task exists. It has nothing to do with which aircraft is more capable, and everything to do with which one carries a particular weapon, and what a stealth aircraft simply cannot do about a radar that never switches on. Air defense is a conversation. Someone has to speak first, and it is never the side you would expect. Every air campaign runs in a specific order, and that order is set by who can afford to be seen. To understand why, start with what destroying an air defense network actually takes, and why that is so much harder than flying over one. Start with what Iran had left. Its air defenses took heavy losses beginning in February 2026. But losses are not erasure. What survived got dispersed, camouflaged, and kept moving. If you cannot fight for the sky, you make it expensive from the ground, and never sit still long enough to be targeted twice. This runs into the physics behind every radar ever built. A radar sees by transmitting. Transmit nothing and it sees nothing. But that energy travels both ways. The same beam that lets it look also announces its location to anyone with a receiver. A radar is dangerous only while it is on, and safe only while it is off. It cannot protect and survive at the same time. Put a stealth aircraft into that. The F-35 crosses the airspace, and the radar never picks it up. So the radar never transmits. So nobody ever finds it. The mission works, and the site that was supposed to stop it ends the night untouched. That is a complete answer for one aircraft on one night, and no answer at all for a war. A campaign is hundreds of sorties over weeks, and most of what flies in them cannot hide. Tankers hold orbits for hours within range of the coast. Transports land at forward fields. Rescue helicopters have to reach a downed crew. Every one of those is a large, slow radar contact. The site that ignored the F-35 will not ignore any of them. So it has to be dealt with. That requires a sequence that runs backwards from instinct. First, make the radar switch on. A site sitting dark cannot be found, mapped, or hit. It only transmits when something worth shooting at shows up. Then, in the seconds after it reveals itself, the objective flips. Take it out before the crew realizes what that emission just cost them and cuts the power. Make it speak so you can find it. Finish it before it stops speaking. That window is seconds wide. Everything in this business fits inside it. Which is why there is a radar somewhere on that map that has been dark since the start of the war. Sitting in working order, off every target list, waiting for something worth turning on for. It will be there when the next strike package comes through. If something has to draw fire before that site can be addressed, the next question is what volunteers, and how it survives. 2 terms get used as if they mean the same thing. They don't. Suppression means forcing a crew to shut their radar down. The hardware survives, but while it stays dark, a corridor opens above it. Fire an anti-radiation missile, and this is often what happens. The operator cuts power to protect the antenna, and the corridor lasts a few minutes. Destruction means the antenna, the launcher, and the command vehicle stop existing. That site does not come back. And an air defense network is not just radars. The launchers, command vehicles, and storage behind them transmit nothing. Silent things cannot be found by listening. They get located through intelligence and removed with guided bombs. The radar is the door. Everything behind it is the house. The July tasking covered both. That is the real reason the deployment was urgent. Nobody needed more aircraft to fly over Iranian air defenses. They needed aircraft that could permanently remove what stealth can only route around. Which aircraft? The options narrow one constraint at a time. Start with the weapon. Killing a radar takes an anti-radiation missile, the AGM-88 family. The first airframe people reach for is the F-35. It can carry the AGM-88 on external pylons, which wrecks the shaping that makes it stealthy and removes the only attribute that justifies the platform for this job. Carrying it internally requires the AGM-88G and the Block 4 software package. The Government Accountability Office puts that package 5 years behind schedule and $6 billion over budget, with the milestone now slipping to 2031. That door closes. The problem shifts to tempo. This is not a single sortie, it is continuous pressure night after night, because launchers move and radars cycle on and off whenever the crews decide. That demands numbers. Stealth is exactly why the F-35 gets held back for targets only stealth can reach. Using it nightly as bait burns the scarcest asset in theater on work a cheaper airframe does better. Then the obvious question, because two supercarriers were right there. In July 2026, USS Abraham Lincoln and USS George H.W. Bush were both in the region. Each carries a Growler squadron. The EA-18G is the aircraft built for this job. Here is where the numbers disappoint. A carrier air wing has exactly one Growler squadron, and a squadron runs about 7 aircraft. 2 carriers means roughly 14 airframes covering a network across a country nearly 5 times the size of Germany. Subtract maintenance, crew rest, and jets held for other tasking, and the number available on any given night is lower. The Growler is not short on capability, it is short on copies of itself. One more name comes off the list, and it is the most plausible one. The F-15E Strike Eagle flies from land. There are plenty of them, and it is cleared to carry the AGM-88. But it has no emitter location pod, so it cannot build an electromagnetic picture while airborne. It can kill a radar that has already been found. The problem is the finding, which leaves one option. The 480th Fighter Squadron at Spangdahlem, pod and weapon integrated for decades, crews trained on nothing else, enough airframes across the F-16 fleet to keep doing it every night. When the ceasefire broke, there was nothing to deliberate over. The official record confirms it. In May 2026, 6 F-16 pilots received the Distinguished Flying Cross for missions over central Iran, protecting a bomber formation from surface-to-air missile fire. The general presenting the award was direct. Without those 6 airmen, the strike that helped end the 12-day war does not happen. The Pentagon did not recall the F-16 because it was the best available option. It recalled it because it was the only platform in the Air Force inventory that could find a radar, kill it, and show up the next night to do it again. Knowing it can do the job still does not explain how. And once you hear the method, most people decide it sounds like a reliable way to get killed. Making a radar transmit sounds simple until you have to answer the obvious question. Give it what, exactly? There is no comfortable way to say this. You give it an aircraft. An F-16CJ flies into defended airspace and waits to be locked up. That is not a risk that comes with the mission. That is the mission. The 480th's motto fits in 4 words. First in, last out. The objection is immediate. Why not a drone? Cheaper, and nobody is in it. Because bait only works if it is convincing. A fire control radar switches on for something with the radar cross-section and flight behavior of a real fighter. A target that reads too small, or moves too predictably, gets called a decoy and ignored. And even when the bait works, it has only solved half the problem. Something still needs to be there with a weapon, ready to fire before the crew cuts the power. That something carries the AASQ-213, the harm targeting system mounted on the intake hardpoint, working entirely by listening. It catches hostile radar emissions, sorts them by signature, and builds a picture, range, bearing, and the type of system behind each return. The pod never transmits, so the crew being measured has no idea it is happening. They illuminate the sky, looking for the F-16. At that moment, they give away their own position. Consider the options available to that battery. Engage, and an anti-radiation missile arrives faster than Mach 2, riding the beam home from as far as 43 nautical miles. Cut power the instant it launches, and older variants genuinely lose the target, but the AGM-88E has already recorded the coordinates and switches to a millimeter wave seeker in the final seconds to find the antenna on its own. Stay dark for the entire war, and the battery survives every night of it without affecting a single one. None of those options produces a radar that is both alive and useful. The crew is not losing because they are outmatched. They are losing because every choice arrives at the same outcome. The only variable is whether they lose the equipment or lose the purpose of having it. One question remains. If the job is to be deliberately locked up, what keeps the aircraft in one piece? It is called Angry Kitten, and it started as a joke. The Georgia Tech Research Institute built it to stand in as the enemy during training, mimicking hostile jamming so American crews could work against it. It fooled the most current radars on the friendly side, convincingly enough that the pilots on the receiving end asked whether they could have it for themselves. The general who told the story quoted them directly, "We kind of need that. Can we have that for us?" What makes it work is the difference between hiding and lying. Old jamming floods the spectrum with noise. The radar knows it is being jammed and cannot see through it, but a screen full of static is still information. The operator knows something is coming and has a rough sense of where. Angry Kitten works the other way. Its digital radio frequency memory catches the incoming radar pulse, adjusts the phase, timing, and amplitude, and sends it back. What returns is technically perfect and completely false. It shows no interference. It shows a contact in the wrong place, or 10 contacts where nothing is. Because the software is reprogrammable, it can be updated in flight. When the radar hops frequencies to escape the jamming, the pod follows in real time. The F-16 is not hiding its shape, it is lying about its shape. The crew on the ground still sees an aircraft, just not the one that is actually there. A single aircraft listening alone still only gets you a mid-grade solution. Good enough to fire a missile at an active emitter. Not good enough to bomb a coordinate the radar has already vacated. Closing that gap is not about building a better pod. It takes a second aircraft, and the reason is geometry. Put an F-16 and a Growler in two different positions and have both catch the same radar pulse. Radio waves travel fast, but not simultaneously. That pulse arrives at the two aircraft microseconds apart. Share that timing difference over the data link and the area of uncertainty shrinks. Add more receivers and it shrinks further. The result is a jump in quality rather than a jump in technology. The solution goes from precise enough to fire a missile to precise enough to drop a bomb, which is the gap between suppression and destruction, expressed as geometry instead of tactics. The Growler's passive listening lives in the ACALQ-218, housed in fairings at the wingtips, working across the spectrum and sorting everything it intercepts: radars, communications, even the control links running to drones. The jamming belongs to the pods underneath. There, the Growler is between generations. The ACALQ-99 has been the tactical jamming pod since the early 1970s. Its replacement, the ACALQ-249, hit initial operating capability in 2021. Growlers flying these missions have gone out with an ALQ-249 under one wing and a legacy ALQ-99 under the other. The Pentagon's own test office reports that the newer jammer, with its current software, is not yet ready for operational use. The most advanced equipment in the American inventory is still being sorted out while the war it was designed for is running. Now the part that makes the pairing work, and it turns on the difference between two categories of radar. Early warning sets sweep broad volumes and rotate slowly. Iran operates the Ghadir, an over-the-horizon array reaching past 1,000 kilometers, and the Matla ul Fajr, a mobile VHF radar built to see what shorter wavelengths miss. Both watch enormous portions of sky, so any given point in it gets illuminated a few times a minute. Enough to raise an alarm, not enough to shoot, and because the beam sweeps through quickly, hard to pin down with precision. Fire control radars work the opposite way. The sets tied to the Bavar 373, the Cordad 15, and S300 batteries have to hold a single target continuously until impact. That continuity makes each one the most detectable emitter on the battlefield. The Gadir speaks broadly to everything in range. A Bavar 373 engagement radar speaks loudly at one face. Only the second says enough to get itself killed, which is why it waits. The early warning network finds the target and passes the handoff. The engagement radar switches on for a few seconds at the end. That is how it stays alive. That handoff is what the Growler severs. Jam the Matla ul Fajr and the communications running between batteries and their command posts, and the missile crews lose the picture they were being fed. Isolated, a Cordad 15 or a Bavar 373 has to activate its own engagement radar and search without help, transmitting earlier, longer, and far more conspicuously than the system was designed to handle. In that moment, the pod on the F-16 and the receivers on the Growler are both listening. Two positions produce one coordinate. The missile goes, and if the battery fires back, Angry Kitten bends the lock off target. The Growler never kills the radar. It makes the radar show itself. Soft kill draws the target out. Hard kill takes it off the board. The reasonable question then, why does the F-16 need to be there at all, since the Growler carries up to 4 anti-radiation missiles of its own? It does, but the two jobs cannot coexist physically. Jamming means putting out energy continuously, and an aircraft doing that is the most visible thing in the sky. It has to hold position, maintain heading and altitude, and stay predictable. Being bait demands the opposite: silence until the right moment, going deep into the worst part of the airspace, and maneuvering hard the instant the lock comes. A Growler running a jamming orbit cannot also be the target it is working to conceal. One has to radiate to protect, the other has to stay quiet to hunt. Because those two jobs cannot share an airframe, the most expensive fact in this story comes into focus. Why is the Air Force borrowing Navy aircraft to clear a path for Air Force bombers? Because the Air Force has not operated a tactical jamming aircraft since the EF-111A Raven went out of service in May 1998. The role went to the Navy and never came back. Every major Air Force strike package now depends on whether Navy assets are available. Run 2 theaters at once and the Growlers cannot cover both. Whatever the Air Force sends without them is working at half strength. The service that owns the bombers does not own the aircraft that gets them through. That arrangement came out of a budget era that assumed nobody would be running large strikes into a modern air defense network again. The bill arrived in this deployment. To find enough suppression aircraft for the Middle East, the Pentagon pulled the 480th out of Spangdahlem, solving one problem by opening another. All 3 fighter wings permanently assigned to Europe were sending aircraft east at the same time. The July scramble is not a measure of how capable the F-16 is. It is a measure of how few there are, and how fast that number runs out when 2 theaters need them at once. The scarce resource in modern air warfare was never the stealth aircraft. It is the ones willing to go first. You can count them on your fingers. Go back to that squadron on the ramp in Germany. Bags still not unpacked. Days before it flew back the other way. They did not return because they were the best available airframe. They returned because the job needed something that could find a radar, destroy it, and come back the following night. The list of aircraft that can do all 3 is 1 line long. This was never a story about generations of aircraft. An air campaign does not open with the airframe that is hardest to detect. It opens with the one willing to be detected. And it works because of something no air defense network on Earth has ever solved. A radar cannot do its job without announcing itself. So the choice to defend is also the choice to be found. Every crew knows this. None of them can build their way out of it. The whole profession is about forcing that choice earlier than they want to make it, at the moment someone is listening. A radar that stays silent survives. A radar that transmits does not. Someone has to make it transmit. Next time you watch an air campaign, don't ask which aircraft dropped the bombs. Ask which one went in first.